elimination reaction. So here what happens, suppose this is the compound CS2, CS2, and you suppose A is attached to CS2 and here A is attached to CS2. So here what will happen, so A2 will be removed and CH2 double bond CH2 will be formed. It means alkene will be formed. Alkene. This is ethene. So here you can say alkene will be formed. And this reaction is also called Seit-Jeffs reaction or Jet-Save reaction. Or rule. Reaction or rule, both are same. So here what happens, dehydrohalogenation. Here what happens, dehydrohalogenation in the presence of alcoholic potassium hydroxide. Alcoholic. What is dehydrohalogenation? D. Hydro means hydrogen. Halogen. Halogens means halogen. So hydrogen and halogen will be detached. Dehydrohalogenation. Say we are taking one example, CH3, CH, CH2, CS3 and C. We can say 2-chlorobutane. So this is the name of the compound. So I will do one modification here to make you understand what will happen. So here CH2 is there, so I will write like this, here H. So you can write CS2 or you can write CH and H, both are same. So see what I told you here. So these elements will be removed. So what will happen? So this compound or these elements will be removed. And what will be made? CH3, CH, double bond, CH, CH3 plus HCl. What happens here? Hydrogen is removed from the neighbor carbon atom, where less number of hydrogen is attached. If you are taking this carbon, so for this carbon, neighboring carbon atoms are this one and this one. But you have to see which carbon is having less number of hydrogen. Here number of hydrogen is 3 and here number of hydrogen is 2. One this and one this. So from less number of hydrogen containing carbon, hydrogen will be removed. Is it clear? So we are going to take one example. So this is CH3, CH and CH2, CH3 and here Cl. Fine. And what will happen when we take potassium hydroxide, alcoholic potassium hydroxide? What will happen? What will happen? So CH3, CH double bond, CH, CH3 plus KCl, K and Cl, KCl and plus H2. So potassium will combine with chlorine to form KCl, and this OH will combine with this H to form H2. Is it clear? This is your first reaction. Now, so this is also elimination reaction. Second type, elimination reaction. What is that? Hoffman rule. What is that? Here, reagents are iodide or CH3 and O minus, or this is what? This is tert butyl oxide. Tert butyl O. And remember this. This is just opposite to Chap's rule. Chap's rule. What will happen here? See, same compound, here Ca, butyl, secondary butyl. What will happen? So, in the presence of any one iodide or tert butyl oxygen, iodide or tert butyl oxygen, this is minus. So here what will happen? So again, here, see, this is CS3. So you can write CH2 and H. For CS3, you can write CS2 and one H here. So here, HCl will be removed. But hydrogen is taken from that carbon, that neighboring carbon atom where more number of hydrogen is attached. So here, this hydrogen will be removed. I told you in Chap's rule, this hydrogen from this carbon was removed. But here, hydrogen from the carbon atom which is having more number of hydrogen, from there it will be removed. Is it clear? And the compound should be here CH2 double bond CH, because here hydrogen is lost, so here double bond will be formed. CH2 CH3. So you can also write hydrogen is removed from the neighbor carbon atom where more number of hydrogen. Reaction is with sodium, this is the compound NaCCH. This is called sodium acetylide. Okay, sodium acetylide. What will happen? See, when alkyl bromide is reacted with sodium acetylide, RCCH will be formed. So this is quite obvious that Na and Br will be removed. Sodium bromide. You have to convert ethanol to but1-ine. So this is conversion. How will you do that? So this is ethanol. From ethanol to but1-ine. So triple bond is there, so ine. See, just now, from the in the beginning of this chapter, you learnt how will you make chloride from alcohol, and I told you the best method is from SOCl2. When you apply SOCl on alcohol, then chloride, corresponding chloride will be formed, OH will be removed and Cl will be attached. So CH3, CH2, Cl will be formed. And just now we have learnt that when you apply sodium acetylide here, it means NaC triple bond CH. When you react sodium acetylide with ethyl chloride, but1-ine will be formed. So this is very important reaction, so I explained here. Other reaction is zinc in methyl alcohol. What will happen when you react any alkyl halide with zinc in methyl alcohol? Say CH2, CH2, Br. It means, what is this? The name of this compound is 2 carbon ethane, 2 bromine, dibromoethane. Dibromoethane. What will happen? Zinc in the presence of methyl alcohol, CH2 double bond CH2. What will happen here? So these both bromine will be removed. These both bromine will be removed. So plus Zn Br2. Or so this is dibromoethane. This is dibromoethane. Now very similar reaction, CH3 Br plus zinc plus Br CH3. It means both are same compound, methyl bromide in the presence of CH3OH. What will happen here? This bromine, this zinc and this bromine will be removed, and CH3 will be formed. So plus Zn Br2. See, this is what? This is ethane and this is ethene. So when dibromoethane is used, then ethene will be formed. But when single monobromo alkane is there, then ethane will be formed or alkane will be formed. Next question. With reaction with manganese. Reaction with manganese. So when alkyl halide is reacted with magnesium in the presence of dry ether, what will happen? R Mg C. This is called Grignard reagent. Very important reagent. Very important. So now we will find this reagent in so many places. So always remember this. Alkyl magnesium halide. Alkyl magnesium halide is Grignard reagent. Alkyl magnesium halide. Never forget this. And other question is, why it is used in the presence of dry ether, or why Grignard reagent is prepared in anhydrous condition? One more reaction you have to understand here. This R Mg Cl. This is Grignard reagent. When it reacts with water, HOH is water, what will happen? What will happen? See, this R will attach to this H, forming RH. It means alkane will be formed. Alkane. We know that R is nothing but alkyl. And magnesium, you can write like this, ClOH. This will be formed. Excuse me. Alkane. Now, question is, why? Grignard reagent is prepared in the presence of dry ether, or in anhydrous condition. Anhydrous means what? In dry condition. Why? First you understand this. This Grignard reagent is very much fond of water. It reacts with moisture and forming alkane. It will react with moisture to form alkane. In this way, your Grignard reagent will be destroyed. Ether is used because Grignard reagent will not react with dry ether. And this is also the point. So you can also be asked why it is used with ether. So answer is Grignard reagent will not react with dry ether. So answer is because it reacts with moisture forming alkane. In this way, property of Grignard reagent is lost, or ether is used because Grignard reagent will not react with dry ether. Next topic is reduction. See, reduction usually occurs in the presence of nickel hydrogen. This is nickel hydrogen. Aluminium plus sodium hydroxide. So these are each reagent which are responsible for reduction. Zinc plus acetic acid. Zinc plus acetic acid. Tin plus HCl. Iron plus HCl. So these are the reagents which are required for reduction usually. So I will give you some examples like CH3Br, methyl bromide. When methyl bromide is reacted with tin HCl, what will happen? See, H2 will be attached. H2. So one hydrogen will go to this and one hydrogen will go to Br. One hydrogen will go to Br and one hydrogen will go to this carbon. So what will be formed? CH4 plus HBr. Very simple. So when you apply any one of them with this type of reaction will be there. Now we take one more example, and that is chloride. So chlorobenzene, this is aromatic compound, so it is also important to learn this reaction. So here if we take aluminium plus hydroxide, Al plus NaOH, and when we heat it, what will happen? Again, two hydrogen will be attached. One hydrogen will go to benzene to form benzene, because here I'm just going to bifurcate it so that you can learn more easily. C, and C. 1, 2, 3, 4, 5, 6. This is benzene, and with benzene 6 hydrogens are attached. But here hydrogen is removed and Cl is attached. So when Cl is removed, then one space is vacant. So at this place, one hydrogen will have to move to cover this place. So one hydrogen is required to make benzene. At the same time, one hydrogen will make bond with Cl, making HCl. Haloarenes, we know what is that. So when benzene is there and one halogen is attached to benzene ring, then this is haloarene. So first reaction is how it is formed. So first is, so we are going to start with preparation, how it is formed. So halogenation reaction. Halogenation means addition of halogen. Very simple. So this is benzene. When it will react with XX, it means halogen, like Cl. What will happen? But one thing is important, you have to know in the presence of which compound. So anhydrous AlCl3. What will happen? Haloarene will be formed plus HX. One question. What else can be used in the place of anhydrous AlCl3? Answer is FeCl3. This is very important. It has come in competitive examinations so many times, and your CBSE board as well. So what else can be used in the place of AlCl3 and hydrogen AlCl3? So our answer should be iron trichloride. Now, second method is diazotization. Benzene attached with NH2. This is NH2 is amine group. NH2 is amine group. So this is called aniline. Remember this, aniline. This is very important compound. When aniline is reacted with NaNO2 plus HCl, then HNO2 will be formed. So you can write any one from this, NaNO2 plus HCl, or simply HNO2. This is nitrous acid. What will happen? Simply on the benzene group, ring, N2Cl should be attached, and this is diazonium salt. This is called diazonium salt. So this is called benzene diazonium chloride. Benzene diazonium chloride. And from this compound you can make a lot of compounds. So now this is diazonium salt. Always write in this way, N2Cl. At N you put plus sign and Cl minus sign. So when it is reacted with CuCl plus HCl, it is called Sand-Meyer reaction. And chlorobenzene is formed. I am telling you only main compound. When it is reacted with copper powder plus HCl. So remember this, here CuCl and HCl, but here copper powder plus HCl, and this is called Gattermann reaction. What will happen? Chlorobenzene will be formed. When it is reacted with potassium iodide and we heat it, this phenyl iodide or iodobenzene will be formed. So I have told there are so many reactions with diazonium salt. So this is benzene diazonium chloride, or simply we call it diazonium salt. And at last I am going to tell you for today one more method. Third one is called industrial method. Industrial method means what? So they can be prepared commercially, and that is called a Raschig process. Raschig process. Very simple. So, two molecules of benzene will react with oxygen plus two molecules of HCl in the presence of CuCl2 at 500 Kelvin. Two molecules of chlorobenzene will be formed with two molecules of H2O. Alternatively, you can write one molecule of benzene, half molecule of oxygen, one molecule of HCl, and one molecule of chlorobenzene, and one molecule of water will be formed. This much is for today's class.